Hi, this is Roopa Prasad, the Assistant Professor, Department of Computer Applications, MITS College. So today we are going to discuss about the topic called as modes of operation, which is a part of CNS, that is a cryptography network security series. So in this one, what we are going to discuss is these are the contents that we are going to discuss. So first, going to the modes of operation, first we discuss what is the main use of why this modes of operation has been devised. That means first we discuss what are the use of the modern block ciphers. Then we discuss the modes of operation. Actually, we have the 5 modes of operations are there. One we call it as electronic codebook mode, and second one is called as a cipher block chaining mode. Third one is cipher feedback mode, and fourth one is output feedback mode, and fifth one is counter mode. Okay, so we discuss the topic. So we go into the topic. Now we discuss the first concept, that is what is a use of modern block ciphers. Okay, actually what happens in symmetric key in cipher mode, that we can also call it as symmetric symmetric key encipherment. Okay, that means symmetric key cryptography. So actually, already we discussed that cryptography is divided into two types. One we call it as a symmetric, and the one is called as a asymmetric. Okay, and this symmetric key cryptography can be done by using the modern block ciphers. Okay, modern block ciphers are nothing but that symmetric key algorithms. What we have discussed earlier, that is nothing but the DES algorithm and AES algorithm. Okay, so this DES and AES works on a block of text of fixed size, that we already know. I'll just see. Okay, so this DES algorithm and AES algorithm works on block of plain text of fixed size. Okay, so DES works on 64 bits, whereas AES works on 128 bits. Already we discussed. So DES algorithm works on plain text of block size 64 bits, and AES algorithm, it is going to encrypt and decrypt a block of 128 bits. Okay, but in real time application, what happens? The message that we have to transmit, the message that we have to encrypt is of variable size, normally which is more than 64 or 128 bits, and still we want to apply these algorithms. Okay, even though our message is larger than the whatever employing by the DES and AES algorithm, and still if we want to apply this algorithm, because these are the secure algorithms, so what we can do means we can have a modes of operation. That is the main reason why these modes of operation has been designed. Okay, I hope clear. So this symmetric key encryption can be done by using the modern ciphers, that is nothing but the DES and AES algorithms. But what is the restriction here? DES algorithm works on 64-bit plain text, whereas this AES algorithm works on 128-bit plain text. But what happens if you want to apply these two algorithms on the message which is larger than 64 or 128-bit, then we can go for the modes of operation. That is a main concept. That's the basic for the modes of operation, why the modes of operations has been designed. Okay, and coming to these modes of operation, we have 5 modes of operations are there. Okay, 5 modes of operations. One is called as the electronic codebook mode, and second one is called as a cipher block chaining mode. Third one is called as a cipher feedback mode, and fourth one is called as output feedback, and fifth one is called as a counter mode. Okay, these are the 5 modes of operation. These are the 5 modes of operation that we are going to discuss. So first we go for the first mode of operation, that is nothing but the electronic codebook mode. Okay, we can simply call as ECB. Okay, we can also call it as ECB, that is electronic codebook mode. Okay, so this mode of operation is a simple mode of operation. That means what? Here we are not going to do anything. Suppose our plain text is larger than 64 bits or 128 bits, we are going to divide our plain text into n blocks of fixed size. That means whatever algorithm we are going to apply. Suppose if you want to apply the DES algorithm, then the block size should be 64 bit. If you want to apply the AES algorithm, then the block size should be 128 bit. So the block size of n bits. Okay, and one more thing we have to consider. Suppose if we want to apply the DES algorithm, so normally the block size should be 64 bits. Okay, so these blocks, how many blocks? The plain text should be the multiple of block size. Suppose 64. Okay, so the plain text can be 64 or 128 or like that. The plain text should be there. Okay, suppose the plain text is not a multiple of a block size, then we have to do padding. Okay, padding means adding extra bits. Adding extra bits is called as a padding. So why for we are doing padding? In order to make the block size, every block should be of the same size. Okay, not more or not less. Okay, for example, if we want to divide the plain text into four blocks, the fourth block should be of n bits only. Okay, if the last block is not of n bits, then we have to make it as n bits. That is the main thing we have to consider here. Okay, and the same key will be used to encrypt as well as to decrypt each block. I will show you in this diagram. So this is a plain text. Now the plain text is divided into blocks. The plain text is divided into blocks of n bits. Okay. So P1, P2 up to Pn. Okay. These are the n blocks. So what we are going to do, we are going to apply this encryption on the n bits. Okay. This n bits will be given to the encryption algorithm. On this encryption algorithm, we are going to make the use of key. And this algorithm is going to provide the ciphertext. Same DES algorithm will be followed here. DES, or we can call it as AES. Okay, like that we are going to have a separate ciphertext blocks. Okay, that's the encryption process. Encryption process. This is the simplest mode of operation. We are not going to do anything. Just we are going to divide the plain text into fixed size blocks, and we are applying the encryption algorithm on the blocks of text. Okay, and coming to cipher decryption process, here decryption is opposite of encryption. Here the ciphertext is the input for the decryption, and this decryption algorithm is going to produce a plain text. On this algorithm we are going to use the same key, that is a symmetry. So for the encryption also we are using the same key, and for the decryption also we are using the same key. Okay, hope you understand. This is a first mode of operation, that we call it as a electronic codebook mode. And then coming to the next mode of operation, that is cipher block chaining mode. Okay, so we see in the diagram itself, in the cipher block chaining mode, what we are going to do means, before going to give the plain text, here also same thing, the plain text is divided into block of plain text, blocks of n bits. Okay, the plain text is divided into blocks of n bits. Okay, so what we are going to do, before giving the block of text, that block of n bits into encryption algorithm, first we are going to perform XOR operation. First we are going to perform the XOR operation. So this XOR operation is performed on n bits, and that is first block ciphertext. Okay, so this is the initial stage. Here we don't have the ciphertext, so we are going to take the initial vector, that is called as IV. So we are going to take the initial vector. By using this initial vector, we are going to XOR this n bits of plain text. First, the n bits of plain text is XORed with IV. So whatever the output, that is encrypted by using the key, and we get the output as a ciphertext. Okay, so this ciphertext is given for the next block, to XOR. Okay, this ciphertext is XORed with plain text block 2, and whatever is the output, that is encrypted using the same key, and as usual it produces output. This ciphertext is given for the next block, like that it continues. Okay, so plain text n, the plain text block n is XORed with ciphertext n minus 1 block, and what is the output, that is encrypted by using the key, and that is a cipher block n. Is it clear? So that what we are saying, that cipher block chaining, the cipher block is going to form as a chain. Initially we don't have the cipher block. For that purpose we are going to take the initialization vector of same n bits, of same size n bits. Now the plain text P1, block P1 is XORed with IV, and what is the output? That output is given for the encryption algorithm by making use of the same key. That encryption is going to produce a ciphertext. This ciphertext is XORed with plain text block 2. Okay, and that will be given for encryption. This scenario follows. Okay, that is the encryption process. And coming to the decryption process, Yeah, what is the decryption process? Here also same thing. But what is the input? Ciphertext is the input and the plain text is the output. Here what happens? We are going to perform the decryption prior to the XOR operation. Okay, in the decryption process, in the encryption process, we are going to perform the XOR operation. Then we are going for the encryption process. Here what happens? Here we are going to perform the decryption. Then we are going for the XOR operation. Is it clear? That is opposite of encryption, and the same scenario follows. Okay, and this we can show in this form, in this form of uh, this can be expressed like this. So, so first C naught. What is C naught? C naught is taken as an initialization vector. So Ci equal, the relationship can be shown like this. Ci, that is a ciphertext block of I equal to encryption of Pi XORed with Ci minus 1. Okay, and decryption C naught equal to IV, plain text equal to decryption of Ci, then it should be XORed with Ci minus 1. Okay, that is called as a cipher block chaining mode. Then we go for the next block, that is called as a cipher feedback mode. Here, then the cipher feedback mode, we are going to take the shift register as an input. Input for the encryption algorithm is the shift register. Before going to this one, here what happens in the previous modes, what we have done, we have divided the plain text into blocks of n bits. Okay, that is equal to the block size of the algorithm. Either it is a DS algorithm or it is a AES algorithm. Here, what we are going to do means, here we are not going to divide the plain text into blocks, but we are going to divide the plain text into segment of S bits. Okay, less than the block. Okay, there we have divided the plain text into block size of n bits, but here we have divided the plain text into segment of S bits. Okay, so here what is the input for the encryption algorithm is a shift register. Okay, so shift register is of the shift register is of B bits, okay, which is equal to the DS or AES block size. Okay, first initially we are going to take the IV, that is the initialization vector. This initialization vector is input to the encryption algorithm. So this encryption algorithm is going to make the use of a key K, and this encryption algorithm is produce the output, is going to produce the output. Okay, in this output, what we are going to do is you are going to select the leftmost S bits. Okay, why? Because the plain text is of S bit segment. Okay, so we have to take S bits only. Okay, this S bits will be XORed with the plain text block segment 1 in order to produce C1. Clear? So what we are going to do, we are going to take the output of the encryption. In this output, what you are going to do, you are going to select the leftmost S bits. So here what we are going to do, we are going to select the leftmost S bits, and this S bits is XORed with P1, that is a P1 of S bits. So we are getting C1. Okay, for the next iteration, what we are going, for the next block, what you are going to do means, this shift register, in this shift register, the content of shift register is shifted left by S bits. Okay, the content of the shift register is shifted by S bits, and this C1 is going to be placed in the rightmost S bits. That is the C1, that is the plain text, the ciphertext of first block will be placed in the rightmost S bits. Then it becomes a shift register. As usually, this shift register is given for the encryption process by using the key, and we are getting the output. And in this output, what you are going to do, you are going to select the leftmost S bit, and it is given for the plain text. So it produces the output C2, which is given for the next block. Like that it follows. And in the last block will be Cn minus 1, that is placed in the rightmost S bit, that is given for the encryption process, and it is going to give the output. From the output, we are going to select the leftmost S bits, and it is XORed with plain text block of n of S bits. Then we are getting the Cn, that is the encryption process. Then coming to the decryption process. In the decryption process, what happens here, what we are going to do means the input. What is the input here? This here also we are going to perform the encryption only. In the decryption process also we are going to perform the encryption only. So here IV initialization vector is taken initially, that is encrypted by using the key. So it is producing the output. So in the output we are going to select the leftmost S bits, and that is XORed with C1. Okay, from the encryption we are going to get the C1. So that if that C1 with that C1 we are going to XOR, then we get the plain text block 1. Okay, the scenario is simple. That C1 is replaced in S bits of the shift register, rightmost S bits of the shift register. That we call it as the decryption process. Okay, so here what we are going to do means, here in the decryption also we are going to perform the encryption only. That is the main thing you need to observe. Okay, then coming to the next mode of operation, what we call it as the output feedback mode. In the output feedback mode, what happens in an earlier mode, what we have observed, after XORing with the C1, that will be given to the next block. Okay, here what happens whenever we have encrypted, whatever the output before going to XOR, that output is fed to the next block. That is the main difference in the output feedback mode. Okay, try to recollect in the cipher. In the previous mode what we have done, we have encrypted, that is XORed with the plain text block, and we get the cipher text. That cipher text is placed in place of the S bits, that is the rightmost S bits. But what happens, the output is directly given to the next block before going to XOR, before going to perform the XOR operation. That is the output feedback mode, and the scenario is same. Okay, here we are going to take the initialization vector. The initialization vector is the input encryption process by using the key. Then we are going to get the output. That output has to be XORed with the plain text block segment. But here what we are going to do, the output is fed to the next block before it is going to be XORed. That is the difference between this previous mode and this mode. Okay, that is the encryption process. And coming to the decryption process, in the decryption process also we are going to perform the encryption only. Same scenario, but here what happens, it is XORed. The output of the encryption is XORed with plain text there in encryption, but here it is XORed with cipher text in order to get the plain text. Okay, that we call it as a output feedback mode. Okay, and finally the last mode is called as a counter mode. Okay, in this counter mode there is no feedback. So how the counter mode works means, so here, okay, first initially we are going to take the initialization vector of n bits. Okay, this n bits will be encrypted by using the key k. Okay, then whatever be the output, that output is XORed with n bits of plain text. Okay, so that it produces the n bits of cipher text. This will not be given for the next round. In the next round, what happens? The counter will be incremented. Okay, the counter is incremented for each block. In order to have the differentiation, we are going to increment the counter. Okay, now the counter will be incremented. Then this n bits of the counter is encrypted by using a key. It produces K2, that is n bits, which is XORed with P2 block in order to give C2. In the same manner in inputs, the counter is going to increment for each block. That is the encryption process. And same scenario, we can go for the decryption also. Here the decryption is also same. Okay, what happens, the counter will be incremented so that we can, here we are going to perform the decryption. Okay, hope you understand, and these are the references which are used to make the slides. And if you have any feedback, you can contact me. Hope you understand. Thank you.